How we displace electrons, part one. Okay, everyone, I want to talk to you now about the kick. And I want to start off with a quote at the top of the page, and this quote is directly from Stephen Mark. It says, "Things are more complex than what I've told you, but I'm just trying to give you an idea of how the technology works. How it is possible to use what appears to be a weak magnetic force to generate large usable amounts of power. The first thing that you need to understand is that we are dealing with electrons. Each individual electron has an associated magnetic field with itself. That associated magnetic field, though it is very small and it is very weak, can be used to generate usable amounts of electricity. And the way is by moving that weak magnetic field over tremendous amounts of copper at a very high rate of speed." Now let's read on in the page, the kick. Theo, who was a member at the overunity.com forum many years ago, once said, "Let's talk about the kick. When the old Edison DC generators were turned on back in the day, they released the kick and killed many workers in the process. A man by the name of Tesla had seen this. He wondered how and why this kick would occur." Now, Tal wrote this that I'm reading in reply to Stephen Mark, and Stephen Mark made a comment about his comment that basically told the whole story of everything that we're working on concerning the electrons at work in the toroidal power unit. Tal once said, "Let's talk about the kick. When the old Edison DC generators were turned on back in the day, they released this kick and killed many workers in the process. A man by the name of Tesla had seen this. He wondered how and why this kick would occur. So he experimented with wire and disruptive discharges from capacitors. It was found by him that this kick could be made so powerful that it could explode wires instantly. This kick came out of the wires perpendicularly. He discharged capacitors into stout wire and through a spark gap. The key to the kick's strength and appearance was in how fast Tesla discharged the capacitors into the spark gap and how fast Tesla stopped the flow of current at the spark gap. Tesla used all types of devices to stop this flow of current: magnets, a flame, counter-rotating engines. His goals were to get the time in which the discharge is stopped to be much quicker. As Tesla did this, he found that the perpendicular radiations, the ones from the wire, caused electrical effects to appear in wires and other copper metal materials near the stopped current discharge." Now, what did Tesla see? He saw the magnetic field of the released electrons, the released negative free electrons off of the wire. He saw the result of those magnetic fields on other wires, copper, and metal materials near this discharge. These electrical effects could be made to create electrons on other wires and copper around his stopped current discharge wire. Now, let me say this. First, you need to understand that the effect of these negative free electrons leaving the wire by stopping the current, and I'm going to explain to you in a moment how we displace these electrons, the way I have found and discovered, and it's really not new, it's in the physics books, to release these negative free electrons from the wire. And it's not hard. But that in itself is not over unity. It's not producing more power than is going in. It's only the beginning process of what we have to do to generate electricity, to generate the wattage and the power that we're after. So this is step one. We have to learn to release the negative free electrons, to displace those electrons off of the wire. Tesla did it by all manner of counter-rotating engines, using flames and magnets, all sorts of things. But like I said, I've discovered a very simple way. Now, do I believe that Tesla discovered this as well? I believe he probably did later on in his life. or he simply never shared it, or it was in one of the patents that Westinghouse purchased that parts were removed or taken out so that no one else could figure this out. But like I said, it's in the physics books, just no one has actually thought about it. And we're going to look at that here in just a moment. Now, let's. Okay, now, in this next picture, I show the collector as the gray wire, and the collector is actually a closed current loop, as we'll get into in future videos. But I want you to notice one thing that I brought out in the last paper that we looked at, and that's this. When these negative free electrons are released from the wire, they discharge perpendicular or at a 90-degree angle to the wire. And this becomes very important later on, because we're going to then take those discharged negative free electrons, we're going to then collect them, move them along great lengths of wire to generate our current and our electricity. Okay, now let's take a look at the next piece. Okay, now this next paper deals, or a piece of the puzzle deals with what is known as Kirchhoff's laws. These are two well-known laws of physics. Okay, so we're not violating nor breaking any physics laws. We're not into dark energy or dark matter or the time-space continuum or the vacuum of space. We're using known laws of physics to generate power, to generate electricity. Kirchhoff's laws. Let's take a look at these. Read with me. Two laws describing the flow of currents in electrical circuits. Putting voltage into a closed loop of any kind turns the voltage to current. The second of Kirchhoff's laws states that in a closed loop of a circuit, the algebraic sum of the products of the resistance and the currents flowing through them is equal to the algebraic sum of all the electromotive forces acting in the loop. If current is generated so that like signals are out of phase with one another by our input voltage signals, your current is out of phase within the closed current loop and you have produced a self-made eddy current. The first of Kirchhoff's law states that the algebraic sum of all the electric currents meeting at any point in a circuit is 0. Now, I'm going to start with that, then I'll go back up to the first paragraph. Anytime two currents touch upon themselves, the algebraic sum of those currents at that instant of time is 0. And it's at that instant of time where the currents touch or overlap, as I like to use the word, that you have temporarily disabled the effects of the flux, and the negative free electrons are then released from the wire. So again, the algebraic sum of all the electric currents meeting at any point in a circuit is 0. And 0 is 0. It's not 1, it's not 5, it's not 10. It is 0. There is no magnetic flux at that point of time to hold the electrons to the wire. I'm going to show you evidence of this and proof of this, but this is one of Kirchhoff's law. The other law is the fact, back to the first paragraph, that a closed loop of any kind turns voltage to current. You have current in a closed loop. Well, if it requires current, not voltage, remember we're not talking about voltage touching itself or voltage overlapping itself. We're talking only specifically about current touching or overlapping itself. And where it touches or overlaps, there is a release of negative free electrons. So within a closed loop or a current loop, we have voltage turned into current, and everywhere that current then overlaps, we have a release of these negative free electrons. Okay, now let's take a look at a picture of this. Now, in this next picture, I show out-of-phase signals. Now, in this picture, I'm using sine waves, but of course, in our actual project, we're going to be using pulses, straight up and down, or as very fast rise and fall times as can be accomplished. But here, for the sake of this drawing, I have sine waves, and you can see, in this case, I have simply created them out of phase by nearly, it looks like nearly 180 degrees. And for the sake of discussion, I want to show you everywhere I have a green circle is, to the left of the picture, is a place that the currents touch. And remember that, according to Kirchhoff's law, the algebraic sum of currents where they touch or where they come together is 0. And it is at that point in between each of those green circles on the left picture that the currents touch that we have a release of negative free electrons from the wire. Now, if you look at the picture to the right, you'll see where I've drawn in each of the kicks, and where those kicks, the kick again being defined as the magnetic field of the electron that can be picked up on other wires, scopes, everything else. Oftentimes it's seen as simply static, but these kicks are the free negative electrons that have been released at the exact points of the touching of the current, or where the algebraic sum is 0. Stephen Mark placed it, or I should say described it this way. He said, what would be the effects on the electrons if you could temporarily disable the effects of the flux? And that's the exact quote. Temporarily disable the effects of the flux. So that's what we're doing. Every time we create currents to touch one another or overlap one another, we're temporarily disabling the effects of the flux and allowing those free negative electrons to be released from the wire. Now remember, again, they alone are not over unity. They alone do not generate usable amounts of electricity, but they give us our little magnets that we're going to use to then generate as much electricity as we desire, as much wattage as we desire. But the first step is we have to have these negative free electrons to work with. Okay, now let's take a look at this in another picture, and this time it is going to show you something else. Now, on this next diagram, I want you to take a look first, starting on the top left corner. And that shows from Kirchhoff's law that the algebraic sum of all the electric currents meeting at any point, any junction or node in a circuit is 0. And it's that 0 that we are most interested in, because it's at that 0, that node, that junction, that we have the current stopped for a moment in time, and we have the release of negative free electrons. Now, if you look at the next picture just to the right of that, at the top of the page, I have where it says 4 kicks produced at junctions, and you'll see 4 green circles. Each of those green circles, again, that's a sine wave, and each of those green circles symbolize or represent the place where the 2 currents touch. Everywhere, again, that electric currents meet at any point, that node or junction, there is an algebraic sum of 0 currents. There is a release of negative free electrons. Now, if you have very little current and it only touches for a very small amount of time, such as a sine wave rather than an overlap, you're going to have a very small release of negative free electrons. But we're going to look at how we would increase that and how we're going to increase that in the device. Now, if you move just to the right of that picture, and where it says junction magnified and shows the large X. And what we've done here is we've zoomed in to show the cancellation of the magnetic flux. And you have two currents coming together. You have the like magnetic poles that repel each other, and the expulsion of electrons at a 90-degree angle at the algebraic sum of 0, according to Kirchhoff's law. Is this physics new? No, it's not. But has anybody ever attempted to use this in such a way to assist in the generation of electricity? I would say that Tesla has, Stephen Mark has, and I have. Now, looking to the right of that, we see how to multiply kicks. And this shows several frequencies, and those frequencies are each touching one another. And again, everywhere where they touch, you have a release of negative electrons. So one of the ways to multiply kicks is to add more frequencies. In our case, we have 3 specific frequencies. Now let's look at the bottom left-hand page where it says pulses. This is how to enlarge the size of the junction. Now I showed very small junctions before because they were sine waves just momentarily crossing at a out-of-phase signal. But now we're going to enlarge the size of that junction, and remember the junction is the algebraic sum of all of the electric currents coming or meeting at any one point in that node. So if you look at the bottom left corner of the drawing, you see where it says pulses. On the left-hand side, we show a single frequency in the blue of 2 pulses. And then on the right, we show 2 frequencies, again of 2 pulses, but this time you'll see that the 2 pulses are nearly completely overlapped. Everywhere the currents touch, almost that complete overlap would be considered a node or a junction. And everywhere that they overlap is a release of free negative electrons. Now, if you look just to the right of that picture, it says magnified pulses 180 degrees out of phase. And again, here you can see that everywhere there is an overlap of current, there is a release, or would be a release, of negative free electrons. Now, for what I have titled really big kick, I show where they are nearly identical, just slightly out of phase, and where they combine together and they overlap, and that's where you have a very large release of electrons. I'm going to show you this in a scope photo here shortly, and you'll see it and better understand it. Next, it says by making F2 times 2.1 the base, F3 times 3.2, and we're not exactly at that, but it's close, the current will overlap perfectly, even now and then, completely stopping the entire wave, the entire current. And when you completely stop it, you have a large release of negative free electrons. So the goal is to have a current loop to produce as much current in that current loop that is overlapping or going to touch itself and one another to release these negative free electrons in a controlled manner. The thicker the current pulse, the higher the amplitude of the kick. And I've also have shown this to be true experimentally. Like magnetic poles repel each other, and expulsion of electrons are at a 90-degree angle. You have a large amount of current, a higher pulse width of current. Where they overlap, you have a larger release of free negative electrons. Now, this next picture here is an actual scope shot of what I'm talking about. This is just one of hundreds that I could show you. But anyway, what you see here on this scope shot is you see where I've created an out-of-phase signal, and I'm showing one of those signals on here, and then the second signal I drew in where it's at. And it is every place, again, that the out-of-phase signal touched, current touched, the algebraic sum of that junction or that node was zero, there was a temporarily disabling of the effects of the flux, and the electrons, the free negative electrons, were then allowed to go free for a moment of time from the wire. And when they went free, their magnetic flux associated with the electron itself, the magnetic field of the electron, then generated what we call a kick. That kick is what you see on the scope as that straight line everywhere the touching of the current took place according to Kirchhoff's law. Now, if you look below that, you see the circuit that I used for this out-of-phase experiment. But anytime you have them touch and you have a means to look at and see what's taking place, you will be able to see those kicks, which again are simply the magnetic fields associated with the free negative electrons. This is not usable electricity at this point, but it is the magnets that the electrons are the magnets that we're going to be using to generate copious amounts of electrical power as we continue on our video series. Now, let's take a look then at the next photograph, at the next picture. Now, looking at this next picture, these photographs are of two scope shots, and the kicks generated at the exact place of current meeting and becoming zero. The current is stopped at those spots. In other words, everywhere you see a green circle in both of these scope shots, in these photographs, that is a place where out-of-phase currents touched, and everywhere they touched, there was a generation or the allowing of the negative free electrons to be released from the wire according to Kirchhoff's first law. And these negative free electrons have an associated magnetic field associated with them, and when those magnetic fields go up against wire or metal of any sort, it generates a kick. Okay, people see these all the time and don't think anything of them. They simply call it static or noise. But that's not what we're talking about. We're talking about purposely putting together the worst case scenario of frequencies to allow the currents to touch one another so that the algebraic sum of those currents touching will be zero, and it will release the negative free electrons that we need to use their magnetic fields to generate copious amounts of electricity. Now, on this next photograph, what you see is a scope shot where I'm able to capture both signals, both of the out-of-phase signals, and where they overlap and the kicks. And everywhere, again, where the algebraic sum is zero, where the two currents touch, is a release of the negative free electrons that produce a kick. Okay, and again, that kick is simply the result of the magnetic field of that electron being seen as it crosses either a scope or a piece of wire or a resistor or whatever it is. There has to be a way to see it. Everywhere it touches, you can look, I circled it in green circles. Everywhere that the current touches, there is the release of the negative free electrons. Okay, now in this next picture, I've drawn out several of the frequencies, 3 of the frequencies to be exact. And again, you can see towards the right-hand side of that picture that they begin to overlap. But everywhere there's an overlay of 2 or more current waves, there is a huge release of negative free electrons, i.e. a big kick. A small release of negative electrons or a small kick everywhere the current touches. These are the 3 input frequencies as their current appears in the iron 3 racetrack, and we use iron 3 or rusty metal iron because it has an additional electron that it can give up for our purposes. in our racetrack closed loop, and their phase relationship to one another. Every now and again they overlay or combine, and nearly completely the entire current becomes a junction or node for a big kick. Big kick defined again as a large release of negative free electrons. We need these negative free electrons because we need the magnetic fields associated with them as we accelerate them after we collect them, and we accelerate them and move them where we want them to go to generate our copious amounts of electricity. So it is vital that we understand what's happening here in the very first step. If we don't have currents that are touching one another, and if we're not generating enough of the release of or the expulsion of these negative free electrons from the iron rusty wire or iron 3 wire, then we will not have sufficient number of negative free electrons to generate the electricity that we're looking for. So this is now vital. In this next scope shot, in this next photograph, these three frequencies of F1, F2, and F3 all combine in a moment of time as current in the current loop. And everywhere that they overlap or combine at the combining, there is a large release of negative free electrons from the iron 3 wire. Now what you see here is you see F1, F2, and F3. Now because of what F1, F2, and F3 are, and because of how they move, they will combine together, and you see in the center of your screen, in the center of the picture, with the big arrow where it says combined, the combining or the total complete overlapping of F1, F2, and F3. Now, if that as current in the current loop overlaps everywhere that current forms a junction or a node or touches other current, the algebraic sum of that moment of time is 0. There is no magnetic field in that moment of time to keep the electrons, the negative electrons, on the wire, and they are released. And because there is so much current in that moment of time, the node or the junction is so large because they have completely overlapped, there is a copious or a large quantity of negative free electrons that then in that moment of time are released from the iron 3 wire. Again, we use rusty iron wire, iron 3, because it has an additional electron to give up as well. All of this helps our cause. Now, what we're going to be doing is we're going to be adding as well 3 additional slave frequencies that are carbon copies or identical, F1, F2, F3. The only difference is they're going to be slightly phase shifted. And these slightly phase shifted, instead of 3 waves coming together and combining, you're going to have 6 waves coming together and combining. And the amplitude will literally be 6 times the amplitude of each of those pieces of current. So it will make a large quantity of negative free electrons be released from the wire. Now we can continue to do that as much as we want, but then you get to a point of producing actually too many negative free electrons, which would not be a good thing. So we're going to start off with 3 frequencies, F1, F2, F3. We'll get into, in other videos, the specifics of those 3 frequencies. And we will be starting off with a slave or a clone of F1, F2, F3. Each one slightly phase shifted, and when they have constructive interference amongst them, they combine and overlap. You will have 6 waves overlapping for a large current kick, or literally a large release of negative free electrons. Well, that, guys, concludes video 1. I Hope that you will study this, that you will learn it, that you will know it, and we will move on to part 2. This is simply the start of the device. This is how we start up the toroidal power unit, is you have to have electrons to work with before we go any further at all. Thank you.